Yep. Okay. First assignment, graph this one. Do you remember what this first number meant? It's a starting number, right? If it was a bank account, it'd be, or a loan, it'd be your principal. So starting number right here. Now, 3 over 2, this is your growth. So this is like saying 1.5 times, right? Isn't 3 divided by 2 1.5? Okay, so when we go over 1, this thing will go up 1.5. But dang it. Dang it. I can't go up 1.5 on this graph. Darn it. Dang it. Shoot. Huh? What do you want to do? All right, well, first of all, it's growth, right? So let's try some different things. Let's see what happens when we plug in some different numbers into here. I'm going to need some help. Let's find a number that works. Let's see what happens when we plug in like 3. 7 will be pretty big. Somebody help me out. Let's go. Need a little bit of help. Okay, before we go to 3, let's try 2. 2. This would be 9 over 4. That'd be 2.25. And what's 4 times 2.25? Is that a whole number? It is. It's 9. So what I just did there was I plugged in 2 for x, right? Whoa. 2 for x, and I got what out of it? 9. Right? Our starting point was 4. I couldn't just go over 1 because it was a fraction like we did on the other assignment. So I had to figure out what number could I plug in here that would generate a whole number. If you went too far away and you got like you plugged in 8, that would be a huge number. That'd be way, way up there, right? So it's probably not too far away. Okay. All right. Next, here we go. Start at 6, and it has growth of 1/3. Yeah, it's going to decay, right? It should be, it's a number under 1. So it should be something like this. So we're going to start at 6. Let's see here. What happens if I plug in 1? If I plug in 1, it'd be 6 times 1/3. What's 6 times a third? No, 6 times a third. A third of 6 is 2. It's like 6 divided by 3. So if I went over 1, there would be a point at 2, just like that. Okay. So what did I plug in? That's my x. What pops out? That's my y. Yeah, Eric? You okay? Okay. Look, we're starting at 2. This is a whole number, so this should be pretty easy. Let's try plugging in 1. Oh, that's not what I meant. That's not what I meant. I meant that gives us 6. So when we went over to the x coordinate 1, we're at the y coordinate 6. Okay, people? Okay, that's the first one. We have 3 today. Oh, gosh. We did 4 last week. We could turn it up even one more notch. Here we go. Writing functions with exponential decay. Few things to look out for. What does it start off as? 900. Here we go. So that's what we're going to write in here first. 900. Now, times. It's an exponential function. Here's one clue. It says it loses 30%. Remember, I think I told you this the other day. What happens if you lose 30% of something? What percent is left over? 70. Thank you. Thank you. 70%. So if we lose 30%, right? We're subtracting 30% from 100%. That leaves us 70%. So that's our growth rate or decay rate. Now, up here, I'm going to put the little variable t because it says t years after it is sold. Okay. If it's losing its value, it should be going down, right? And a number less than 1 signifies decay. So when you see this, what if it said adds 30%? What number would you put in there? Yeah, 1.3, right? Or 1.30, whatever you want to say there. There's one other phrase that you're going to see. Well, we're not quite there yet, but this is a fraction. It says in Sylvania, it's decided to reduce the number of its illiterate citizens by 3/5 each year. They just decided it's a goal. All right, this year there are 9,000 illiterate people. So let's start with that. Now this is a little bit, this can be a little confusing here. So I'm thinking to myself, what do they mean by reduce the number of its citizens by 3/5? I'm thinking this could be one of two things, right? Either we're taking away 3/5, or we're just multiplying by 3/5, so it's just going to be 3/5. Which one do you think? You think the first one? Okay, we'll try the first one. So that would mean 2/5. Kind of, I mean, I could see it either way. I really don't know what the answer is. Which one are you going to go for? Hey, look, we got it right. Now, when you see a phrase that'll say by a factor of, this is like we did the other day, you write that number in there, okay? If it said by a factor of, that's the number we're going to write in there. Okay, so that's what led me to think it was this in the first place. We did one like this. Okay, if you have 800 pine trees and a disease is introduced that kills 1/4 of the pine trees, how many are left? 3/4. Okay, so that's just another one. Very similar to that. Last assignment. Here we go. Complete the equation. Now, we have a table. That's all we have. Dang it. Shoot. It tells us when x equals 0. So like on a graph, when x equals 0, it's right here. Isn't that our starting number? Yeah, it is. When x equals 0, the graph is at 12. And then when x equals 1, the graph is at 2. So it's decay, right? It's decay. So it should be a fraction. What fraction is that? How do we go from 12 to 2? Divide by 6, which is the same as what fraction? 1/6, right? If you multiply by 1/6, it's the same thing as time or divided by 6. But you can't say divide on these. So you've got to turn it into a fraction. Oh, wait, it's not a t. What is it? That's an x right there. Let's do one more. The starting point is 5. The next point is at 8. Oh, well, that's weird. What did they multiply by? What do you think, Eric? Well, here's how it works. 1.6, you're correct. You could also go backwards and divide, and that's what Trev did there. All right, so go from 8 to 5. right? Well, that's the same thing as going backwards in this multiplication, right? How do you go backwards in multiplication? Divide. So take 8 divided by 5. You would get 1.6. Now, let's say this wasn't an exact decimal. You could just use the fraction. Just like that. Okay? There we go. I'm going to assign these to you. Congratulations.